In this video, we'll be going over section 9.6, which is on matrix algebra. The first thing we've already talked about, but we'll just remind you the size or dimension of a matrix, how we refer to how big a matrix is. And one new thing in here is going to be its entries. So how to refer to a specific spot in a matrix without having to use really cumbersome wording. And then we'll talk about three things you can do with a matrix. The first one, you can multiply a matrix by a constant or a number. You can always do that, and we'll see how to do that. You can add and subtract two matrices. This has to be a little specific. You can't just always add and subtract matrices, as we will see. And the last topic is multiplication of two matrices. This thing is kind of weird in how it works. I'll go ahead and warn you that now, so when we get there you'll understand, because the way addition and subtraction of matrices works is it's kind of would work if you had to guess how to do it. Multiplication wouldn't work that way, and you won't be able to do it whenever you want. All right, so just as a very quick reminder, we say a matrix has size or dimension m by n if it has m rows and n columns. Now there could be a use for you to be able to refer to a specific entry in a matrix, and this little section here is how we do it. Suppose A is a matrix. Often you can see A written, it should have an extra parentheses there, that shouldn't be there. A with subscript ij, to mean that Aij is the entry in row I, column J of matrix A. So to explain what we're doing here, we want to enter the following for this given matrix. Right, the first one says we want to figure out A11. Now in words, what this means is we want the entry in row 1 and column 1. Right, sometimes you will see these separated by a comma, but not often and not always, because you're never going to really see a matrix with more than 9 rows or columns. So it's understood 1 1 means row 1 column 1. Down here 2 3 will mean row 2 column 3. But the way we number the rows is from top to bottom, like we have been doing before. So we've really done this for entireties of the rows and columns. Now we're just talking about how to do it for a specific spot. So row 1 is the top one, row 2 is the second one, row 3 is the bottom one, column 1 is the most left, and then the number goes up as we go right. So this is column 1, this is column 2, this is column 3, and this is column 4. Right, and you can see the entry in row 1 and column 1 is 1. It's right here. Okay, row 1 and column 1. There's only going to be one spot for it. All right, the next one we want is in row 2, column 3. Row 2 is right here, the second row, and we go over to the third column and see that it is -2. We're just referring to the entry. All right, next one, A32, row 3, column 2. Row 3, column 2. Yeah. Row comes before column, so don't accidentally mix those up. Row 3 is down here in column 2. We go over 2, and we see that that entry is 0. So A32 is 0. A14, we're in row 1 and column 4. Row 1 and column 4. Row 1 is right here. We go over to the fourth column, which is over here. It's also 0. And I'm writing that number backwards. A14. 1 4. Row 1, column 4. Okay, so we have many zeros in here. That's fine. The last one, A41, that's asking us what is in row 4 in column 1. And this one's just really, you notice we don't even have 4 rows, so this is D and E. There is not a 4th row. You got to make sure you really remember row comes before column. That's going to be very important when we do matrix multiplication as well. Row comes before column. Right. But that's just some additional practice with this stuff. Really, the emphasis here is row comes before column, no matter how you refer to a matrix. If you're referring to the matrix as a whole, if you're referring to a specific spot in the matrix, row comes before column. All right, now multiplying matrix by a number is just pretty much one of those things. If I never told you how to do it, you'd probably still be able to guess how to do it. So if you have A be a matrix and C is any number, then C times A is the matrix gotten by multiplying each entry in A by the number C. So in words, multiplying a matrix by a number means multiply every entry in the matrix by that number. And so if we want to compute negative 2A, all we do is we take our matrix here and multiply everything by negative 2. Right. Once you do that, yes, it is kind of annoying to multiply this many things by negative 2, but once you do that, you are done. Oops. Did not mean to put an equal sign there because that's not going to be what I'm talking about. So if we multiply everything by negative 2, we first row negative 2, negative 4, negative 8, and 0. Second row we got negative 6, 0, 4, and negative 4. And the third row we got negative 2, 0, 8, and 16. That's it. And the homework, you've seen matrices by now. You just fill in the numbers and the blank spots. But the nice thing about multiplying matrices by a number is you can always do it. It doesn't matter how big the matrix is, you just multiply everything by that number. All right, now adding and subtracting matrices. I, for some reason, have giant white space. Adding and subtracting matrices, pretty much it works how you would guess, but you can't just add or subtract matrices whenever you want. Okay, so the definition of doing it, let A and B be two M by N matrices. Then the matrix A plus B is defined to be the M by N matrix, which each entry is gotten by adding the corresponding entries in A and B together. Meaning row 1, column 1, you add those two together. Row 2, column 1, you add those two together. All right, so the above definition tells you matrix addition works how you would want it, which we'll see. And subtraction would work the same way. There's not really a separation for subtracting because subtraction is just addition and then you multiply B by negative 1. All right, but we'll practice some examples. The important thing here, once again, what this says is they must be the same size to add and subtract. They must have the same number of rows and columns. And that's for add and subtracting. And I know I have that written below there, but just really emphasizing this point. All right, so here we have two matrices that are the same size. Matrix A is a 2 by 3 matrix. There's 2 rows and 3 columns, and B is also a 2 by 3 matrix. So we can add them and subtract them. So now that we see that we can add and subtract these, let's go ahead and do it. A plus B. One thing highly encouraged whenever you do anything with matrices is just write them in the order you're supposed to do them. With addition, you'll see that it won't really matter. A plus B and B plus A are the same. Subtraction, of course, that matters because it matters for numbers. 3 minus 2 is not the same as 2 minus 3. But multiplication, you will see the order matters a lot. So I'm going to just start by actually writing them in the order you're supposed to. We're doing A plus B. Now what the method to adding and subtracting matrices is just adding and subtracting the corresponding entry, meaning if I add the first row and first column entry in both matrices, that's what goes in the first row, first column entry of the result. 0 plus 3 is 3. Then, if just depends on how you do it, but if you move over to the first row and second column, we got -5 and 5. We add those together. And -5 plus 5 is 0. And you just do that with all the entries. So here, moving over to the first row and third column, -5 plus 1 is -4. And you do the same thing in the second row. Once you run out of entries, you are done. We go down to the second row. First column, add those two. -1 plus -5 is -6. 3 plus -4. 3 minus 4 is -1. And finally, the last entry, 1 plus -3 is -2. And this is the matrix A plus B. And matrix addition comes pretty quickly, especially if you don't have any numbers out here, which we'll see. Same thing with subtraction. But it is nice just to write your matrices down, because what's often the case when you do stuff with matrices, you're doing a lot of different arithmetic steps. It's easy to make a mistake. Just keep your work organized. Right, so A minus B, gonna work the same way, except we're gonna subtract the entries. I'm gonna do the same thing I did before. I'm gonna put A on the left and B on the right. And I'm linking them this time with subtraction because that's what we want to do. And simply put, if we want to compute this, we do the same thing with addition, but subtraction. Okay. So in this first entry, right, I'll just kind of color code it the same way as before to emphasize it's the same. 0 minus 3 is -3. Doesn't matter the order you do it in. If I go down to second row next, -1 minus -5, -1 plus 5 is 4. And the first row and second column, -5 minus 5 is -10. In the second row, second column entry, 3 minus -4 is 7. 3 minus -4 is 7. And in the first row, third column entry, -5 minus 1 is -6. And in the third column, second row, maybe I should say it the correct way, second row, third column entry, we got 1 minus -3, which is 4. Right, now on that website I showed you before with doing row reduction, row operations with matrices, reduced row echelon form, and determinants. You can do matrix addition and subtraction the same way. Now, this is typically pretty quick. You can certainly check your answers, but I'm mainly interested in checking our answers with the multiplication part. So when we get there, we'll check those. All right, the last one I have here is just combining the two things we've done so far. So we know we can multiply matrices by numbers. We know we can add matrices together and subtract them. So the last one is 3a plus 2b. Now, the order you do this in matters. Think about your order of operations. Multiplication comes before addition, meaning we want to do 3a first, compute 3a, and then compute 2b. So I'll do those on the side here, and then add them together. Right? So we multiply first by the numbers, order of operations. Then we will add the results. And this is just the way I like to organize my work, because multiplying a matrix by a number is so quick. I'll scroll back up to remind you of matrix A, and we're multiplying everything in matrix A by 3. Okay, so 0 times 3 is 0. This is also matrix A, I'll just remind you. So multiply this by 3, we get negative 15. Negative 5 times 3 is negative 15. Negative 1 times 3 is negative 3. 3 times 3 is 9. And 1 times 3 is 3. Okay, so multiplying everything in matrix A by 3. Matrix B, which is right here, we're multiplying everything by 2. So 3 times 2 is 6. 5 times 2 is 10, and 1 times 2 is 2. Negative 5 times 2 is negative 10. Negative 4 times 2 is negative 8. Negative 3 times 2 is negative 6. All right, and now we add these. We have 3a, we have 2b, we want to add them. Once again, just going to write it out. What it looks like, because I don't like trying to read it in any type of way that's not natural to me. Okay, so this is 3a, this is 2b. And then we add these together. 0 plus 6 is 6. Negative 15 plus 10 is negative 5. Negative 15 plus 2 is negative 13. Negative 3 plus negative 10 is negative 13. 9 plus negative 8 is 1. And 3 plus negative 6 is negative 3. And that's our matrix addition and subtraction, and combined with scalar multiplication, multiplying by a number. All right, but that's the only way to do this. You cannot, skip order of operations. You can't say 3 plus 2 is 5 and then something like that. It has to be done like this. All right, one thing that most online calculators will not do is it probably won't do this at all, like as once. Meaning you have to figure out 3a and 2b yourself anyway, and then add those together to check. All right, but the last thing in this section, actually, let me rephrase that. Before we get to the multiplication, I just wanted to have some examples in here of matrices you can't add because they aren't the same size. Okay, so the first pair here, I have it outlined. If you just notice that they're not exactly the same size, that's why we can't add them. So this first pair, the reason we can't add them is this is a 2 by 2 matrix. This is a 2 by 3 matrix. If we tried to add them, we could add the 0 and the 3, the negative 5 and the 5, the negative 1 and the negative 5, and the 3 and the negative 4. But we don't have anything to add to the 1 and the negative 3. So that's ultimately why we cannot add these matrices, is there's nothing to add with it. And any two matrices that aren't exactly the same size cannot be added. It doesn't matter if they have the same number of rows. If they don't have the same number of columns, it doesn't work. If they have the same number of columns, they still need to have the same number of rows, and so on. All right, so that's just some examples of things you cannot add. You'll see on the homework, most of the problems will start with, can you add or subtract these two matrices? Yes or no. And if you cannot, put D and E for your entries. So just read the directions on that. All right, the multiplication of two matrices. I'm not really going to be able to describe how you multiply very well without going through the example. It's sort of like the determinant. You just kind of see how it's done alongside. But the definition of multiplying two matrices does really tell you when you can do it. So it says, suppose A is an n by n matrix and B is an n by p matrix. What you'll notice here, as I'll outline, is if the column number here, n, and the row number here, n, are the same, that's when you can multiply. And I'll point out that when we do the problem, because whenever you write down multiplication of matrices, you want to know if you can multiply it, and also if you can multiply it, how big it will be. So the result of how big it will be is actually the two outside numbers, m by p. So the matrix AB, set A times B, is an m by p matrix. Right, see, m by p. Size of the resulting multiplication is the matrix which the entry in row I and column J is gotten by multiplying the entries in row I of matrix A, B and F, of, by the corresponding entries of column J in matrix B, then adding them together. Right, like I mentioned before, it's pretty complicated to put in words. You'll see how we do it. But this first example, we have two matrices here. We'll multiply A times B and we'll multiply B times A. What you will see is that the order of multiplication matters. A times B does not equal B times A. You have to write them in the correct order. All right, so the first thing to do when I have to multiply matrices is do like we did with addition, write down the matrices in order. I want to do A on the left, 3, negative 5, 5 and negative 4, and B on the right, 0, 4, negative 2 and 1. And what I do here, see, can we multiply these things? And if we can, how big is the result? Write the size on top of each. So this one on the left is a 2 by 2 matrix. We got 2 rows and 2 columns. The one on the right is also a 2 by 2 matrix. If you do this step, it saves a lot of frustration as far as what we're going to do next. So you write the size of the matrices. All right, now what this part is saying up here is if the two middle numbers match, then we can multiply them. Two middle numbers being right here. If these match, which they do, 2 equals 2, that means we can multiply them. Right, and then the size of the result is the two outside numbers in that order. So when we multiply them, the result is a 2 by 2 matrix. So the result is a 2 by 2 matrix. This is how I start all my matrix multiplications problems, is by organizing it. You figure out if you can multiply them. If you can, how big is it? Once I see how big it is, I like to make a 2x2 matrix, but with all blank entries. Right, and I'm leaving big spaces for a reason. What goes in each entry isn't just as simple as adding and subtracting like last time. Right, so this is my result matrix with blanks. All right, so however big your matrix is, you want to kind of make a resulting matrix like this. Leave some space for each spot, but it is very helpful to do this. All right, now what goes in each spot is sort of described here. You multiply across the row and down the column that corresponds to this entry, meaning for this entry right here, this entry is row 1, column 1 of our result. Right, when we get down here, it would be row 2, column 1, and so on. The pattern of what we do continues. Right, so what you do to figure out this entry is you multiply across row 1 and down column 1. Across row 1 on the left, down column 1 on the right. Right, remember, row comes before column. Row before column. Okay, so we go across row 1 and down column 1. And I'll write across row 1 on the left one, down column 1 on the right. All right, you always go across the row on the left one and down the column on the right one. Okay, so this left matrix here will go across, the right matrix here will always go down. All right, so the way it looks when you actually multiply out what goes here, you start with your first entry. First entry here in row 1 is 3, and the first entry in column 1 here is 0, and we multiply those two. We multiply 3 times 0. All right, you start by multiplying the first things in the row and column you're supposed to use. Then you add. You always add. And then you go across row 1 over here and down column 1 on the right here, meaning we move over to 5. We're at 3, we move over to 5, and we do 5 times the next number in the column down here, which is 4. Right, we move across and down. And when you run out of places to move, you are done. Right, so we got 3 times 0 is where we started. Then we added. We moved over to 5 and down to 4. We don't have anywhere more to go over, right or down, which means we are done with this entry. Right. But if you use the words that we're describing here, it really helps. Right, so we'll simplify this in a little bit. I'm just going to leave that alone for now. This entry here is in row 1 and column 2. Right. So what we do is you say the same thing as last time. Row comes before column. We're going to go across row 1 in the left matrix and down column 2 this time in the right matrix. Okay. So we're in row 1. We're in the same row as before, but we're going down column 2 on the right. Okay, so we start at 3, the left part of row 1, times the top part of column 2, which is -2. Got 3 times -2. We always add. That's never going to be subtraction. You always add. And then we move across row 1 to 5 and down column 2, which is to 1. We do 5 times 1. Once again, at this step, we've exhausted all the entries. We have nowhere else to move right. We have nowhere else to move down. All right, so once again, I'll reiterate. Row 1, column 2, we go across row 1, down column 2, 3 times 2, plus 5 times 1. If you organize your work, if you just say in your head or write out what you're supposed to do, with enough practice, this comes pretty quickly. It's another one of those things. A lot of the things with matrices, once you practice enough, it's just really a lot of arithmetic. All right, so this entry here, this is row 2, column 1. All right, so we want to go across row 2, right? We always go across the left row, left one, and we always go down the column on the right one. That's never going to change as well. So we go across row 2. We're going to go across row 2 as we go down column 1. Start at the left in the top. We got -5 times 0. Then we add. We always add. Don't worry about if there's minus signs. We always add. -5 times 0. Then we add. We go across row 2. -4 times down column 2, 4. So we got -5 times 0 plus -4 times 4. And then finally, the last entry over here, if we say out the entry name here, that is row 2, column 2. And we are going to go across row 2 as we go down column 2. All right, so start at the left of row 2, -5, and top of column 2, -2, and multiply those. -5 times -2. And then we add, we go across and down, -4 times 1. Right. Now once you've got this set up, you can just simplify each number and that will be your answer. So each entry is on its own. This first one here, you don't need to write these blanks anymore, but I'll do it just to emphasize finishing up. We've got 0 here, plus 20 is 20. Over here, in row 1 and column 2, we got -6 plus 5 is -1. Down here, we've got 0 plus -16 is -16. And the last entry here, 10 minus 4 is 6. And this is the matrix A times B. Now what I'll go ahead and do is show you that on the calculator. Well, yeah, I'll show you on the calculator how to multiply matrices to check your answer, and then also on the computer program. Okay. So if we go to the calculator, we're going to have to make 2 matrices here. Go to our matrix menu, do one of them first. Matrix A is a 2 by 2 matrix. Now these are just placeholders. If your matrix A from before that you had filled out you think you might need again, just put it in a different one. But matrix A, the first one is 3, 5, -5, -4. So we got 3, 5, -5, -4. Did I hit Ellen? Go to. Somehow, -4. That is matrix A. We also need to make matrix B before we try to multiply them. Matrix B, 0, -2, 4, 1. So we go back to our matrix menu, go to one you haven't used, matrix B. It is a 2 by 2 matrix. And I already forgot what it was. 0, -2, 4, and 1. All right, now if you want to multiply matrices, go to our matrix menu. Remember, the order matters, but there's no special multiplication. You do matrix A, hit enter on that, times, and then go to matrix B, and it'll multiply them. And we got our answer. All right, so as we'll see, when we do B times A, the number comes out different. Right, but I'm going to go ahead and do B times A. The setup is all the same, but the order you have these written in are flip-flopped. So when you do this out, it will be very different because you'll be going down the rows and across the columns of the opposite matrix. All right, so matrix B is 0, -2, 4, and 1. Matrix A is 3, 5, -4, sorry, -5 and -4. Once again, just because you can do A times B won't actually mean you can do B times A. You want to check it. They're both 2 by 2 matrices here. And it's a good habit just to check them like this. The inside numbers are the same, so we can multiply. And the result is going to be a 2 by 2 matrix. So it is going to be the same size as before. It's going to be a 2 by 2 matrix. Now I won't go as detailed in the steps, just keep along here. Extra practice doesn't hurt. We got 0 for the first row and first column. We got 0 times 3 plus, go across the row down the column, -2 times -5. First row, second column, we go first row and second column. We got 0 times 5 plus, then across for row 1, -2 times -4. Down to row 2, column 1, we go across row 2 and down column 1. We got 4 times 3 plus 1 times -5. And finally, row 2, column 2. We got 4 times 5 plus 1 times -4. And let's see what we get here. This is 0. This is 10. 0 plus 10 is 10. The entry over here, row 1, column 2, we got 0 plus 8 is 8. Entry down here, row 2, column 1, we got 12 minus 5 is 7. And the last entry here, row 2, column 2, 20 minus 4 is 16. And as you can see, this is very different matrix from the first one. Okay. A matrix is different if even just one of its entries is different. For this one, they all happen to be different. That's just probably gonna be what happens most of the time anyway. Right, but you can check your work again. You could just reverse. We already have these matrices made, so just reverse the order. Do B times A. And you see we got that matrix 10, 8, 7, 16. So very nice way to check your work. All right, so the last one I have here is just another practice one, but really to emphasize the importance of doing that preliminary step. So what we want to do is first determine whether the matrices can be multiplied in the given order, and if so, perform the multiplication. All right, so first question is A times B. In that order. We see from last part now, it's very important that you do it in the order, because even if you can do them both, most of the time it will be a different answer. So this is matrix A, and then matrix B. And the question is, can we multiply these? Okay, so matrix A is a 3 by 3 matrix. Matrix B over here is a 2 by 3 matrix. And we can see right away that the middle numbers are not the same. 3 and 2 are not the same. These cannot be multiplied, in this order at least. Right, so, you know, as far as the question goes, we can't multiply them, which means A times B does not exist. I'm not going to do this in the calculator, but if you try to multiply two matrices that you can't actually multiply in your calculator, it will give you an error because it understands you cannot do it. All right, let's reverse the order now. If we want to do B times A, okay, B is 0, 4, -2, 1, 3, and 6. Matrix A, a little bit bigger. We have 3, 5, 2, just copying this one. A -5, -4, 0, and 0, 1, 4. And if you write the size above here, this is 2 by 3. This is 3 by 3. Which means they can be multiplied. And the result is the two outside numbers, which is a 2 by 3 matrix. The result of our multiplication is going to be 2 by 3. Right, so let's go ahead and fill in some spots for that. This has 2 rows and 3 columns. A little bit bigger. 2, 3. That's our result. And we'll do exactly what we did before. Go across the row on the left as we go down the column on the right. So this first one here, row 1, column 1, we get 0 times 3 is 0. Plus -2 times -5 is 10. Plus, continuing, we got 3 times 0, which is 0. Right. Row 1, column 2, we go across row 1 as we go down column 2 now. 0 times 5 is 0. Plus, -2 times -4 is 8. Plus, 3 times 1 is 3. Right. And then row 1, column 3 here, we got 0 times 2 is 0. Plus -2 times 0 is also 0. Plus 3 times 4 is 12. Right. And then down to the second row entries. Row 2, column 1, we got 4 times 3 is 12. Plus 1 times -5 is -5. Plus 6 times 0 is 0. Row 2, column 2, we go across row 2 and down column 2. 4 times 5 is 20. Plus 1 times -4 is -4. Plus 6 times 1, which is 6. And then our last entry here, row 2, column 3. Go across row 2 and down column 3. 4 times 2 is 8. Plus 1 times 0 is 0. Plus, and then finally, 6 times 4, which is 24. Now just simplify each of these numbers. We'll be good to go. This first entry here is 10. Then moving to the right, we get 11. Then moving to the right, we get 12. Then below 12, minus 5 is 7. 20 minus 4 is 16, plus 6 is 22. And the last entry, 8 plus 24 is 32. All right, but you can check this one on the calculator. This one I'll show you in the computer. Let me just write it down on my paper so I don't have to go back and forth. All right, so if you want to multiply these, remember the order matters very much. You can't even do A times B, which we saw. If you want to do B times A, multiply them in this order. When we go to the online calculator, go to matrix multiplication. Matrix A dimension, this is the one on the left. Our matrix A, the one on the left, was a 2 by 3 matrix. And matrix B on the right was a 3 by 3 matrix. All right, so that one's already set up for us. We set our matrices and then fill them out. So our one on the left was 0, negative 2, 3, 4, 1, and 6. And the one on the right was 3, 5, 2, negative 5, negative 4, 0, 0, 1, and 4. And if we calculate, we got 10, 11, 12, 7, 22, 32, which is exactly what we got. So it checks it real quickly. I think one thing this does, if I do it, if you mess with this number, these are the two numbers that have to be equal, so it's gonna make these two equal. So if you don't do the checking thing and you're trying to multiply two matrices, if you can't actually do it, you won't actually be able to even plug it in here. All right, so our first one we did was tried to do was 3 by 3, and then a 2 by 3. If we try to do 3 by 3, this is already 3. This, to make this 2 by 3, we'd have to make this 2, but it switches that to 2. But you can't actually do it. All right, but that is matrix multiplication, and this concludes our matrix algebra section.